Welcome back to ThinkCosmos, where we ponder the universe's deepest secrets and wonders. Imagine looking into the night sky and realizing something is missing. Not just a few stars, but an entire class of stars that don't emit light, that don't glow, don't want to be seen. Today on ThinkCosmos, we explore one of the most mysterious and haunting possibilities in astrophysics. Dark stars. Not metaphorical, not poetic, but real stars that are invisible. Are they out there? What would they be made of? And most importantly, why can't we see them? Let's begin by understanding what we do see. For most of human history, we defined stars by their light. Twinkling pinpricks in the sky. Nuclear furnaces burning hydrogen. Bright tea. Party. Glorious. But what if that's only part of the story? Modern astronomy relies on light. Visible, infrared, ultraviolet, X-ray, white dot. We look for the electromagnetic radiation that celestial objects emit. But what if something out there doesn't emit light at all? What if it never did? Or worse, what if it stopped? A dark star is a theoretical object that acts like a star, but doesn't shine. Not because it's dead, but because it's different. Some models suggest dark stars could form in the early universe, made not of normal matter, but dark matter. Instead of nuclear fusion, they'd be powered by dark matter annihilation, a strange process where dark matter particles collide and release heat without light. These stars would be cooler, larger, and far more mysterious, and completely invisible to our telescopes. Unless we know exactly how to look. Here's the unnerving part. If dark stars exist, we wouldn't see them. Not with our eyes. Not with normal telescopes. They wouldn't shine. They wouldn't reflect. They'd just be there. Massive. Silver. Ancient. Tot. Lurking in the galactic halo. Or drifting between stars like cosmic ghosts. They might even have planets orbiting them. Whole solar systems, hidden in plain sight. It's like the universe is a stage, and the biggest actors never come into the spotlight. It sounds counterintuitive. Why make a star that can't be seen? But the universe doesn't care about visibility. It cares about physics. Dark stars could be the result of the early universe being flooded with dark matter. In those first moments after the Big Bang, conditions were different. Clouds of gas might have collapsed under gravity. Not into glowing fusion engines, but into dark matter-powered giants. Not hot, not bright, but huge, cold, slow, and long-lived. Some may still be out there, unchanged since the dawn of time. If they don't shine, how could we find them? There are clues. If a dark star passes in front of a brighter star, it could cause a gravitational lensing effect, bending light and revealing its presence. Or maybe it creates strange infrared shadows, warps space, or emits faint gravitational ripples. Some scientists believe we may have already spotted anomalies in star catalogs. Objects that don't behave like normal stars, that aren't quite black holes, but aren't quite visible either. These could be our first glimpses of the unseen. Here's where it gets truly strange. What if a dark star had planets? Could life evolve in such a system? If a planet was close enough to a warm but non-luminous, dark star. It might receive heat. Without light. Imagine a world that never sees a sunrise, where life forms evolve under a dim, eternal twilight, where light is not a given, but a myth. Could intelligent life arise in such darkness? Would they even understand what light is? And if they ever received our signal, filled with photons, lasers, radio bursts, would they think we were the weird ones? The scariest idea isn't that dark stars exist. It's that the universe might be full of them, and we just don't know, because we can't see them. We've built our cosmic understanding on light. But what if light is only a fraction of the picture? What if invisibility is the norm? Invisibility is rare. A universe of shadow suns, of dark networks, of civilizations we'll never detect, because they were born in the blind spots of our senses. Maybe the real cosmos is hidden, not because it's secret, but because we're still learning how to look. So what are dark stars? Lost giants from the early universe, stealth suns powered by unknown physics, or the homes of unseen civilizations? We don't know yet. But every year, our instruments grow more powerful. Our ideas grow bolder. And we start to realize the universe isn't just full of things we don't understand. It's full of things we haven't even learned to look for. Thanks for listening to ThinkCosmos. Subscribe for more journeys into the unknown, where the deepest truths hide in the darkest corners. Until next time, keep looking up. And remember, what you don't see might be the most important thing of all.